Hi everybody, I'm Greg Fishel and welcome to bonus weather video number 1 for this week. And I've entitled this Thickness, Rain, Snow, Ice, and Other Goodies. And at the end of this presentation, I'll tell you how the National Weather Service office in Raleigh made a huge contribution to trying to forecast these different precipitation types. Again, that'll be coming up at the end of the presentation. So let's delve into things here. Twice a day, every day, weather balloons are sent up all over the world at exactly the same time to get a snapshot of what the upper atmosphere looks like. And so one of the things that we measure is how high you have to go up to reach a given pressure level, okay? So in other words, if I label all of these, and let's see, that I'm I'm in front of that one label, but this bottom line here is 1,000 millibars, okay? Then the one up above that is 850, 700 millibars, and 500 millibars. And if you then take a look at the distance between those two levels, any two levels, then you calculate the thickness between those two levels, and that can then be used mathematically to calculate the temperature of the layer in between those two levels, okay? So if you want to find out what the thickness would be for an average temperature of 32 degrees through that level, you simply plug in all the numbers into the equation and you get the answer, and you can use that as a tool for rain snow forecasting. Now, way back in the day, back when I was in college, this is just after the dinosaurs became extinct, not long, but just a little bit afterwards. The 540 line was used for rain-snow boundary forecasting. This was the gospel, okay? You looked at the 1,500 millibar thickness, which is like 3.5 miles thick, and if the thickness was 5,400 meters, you just left that last zero off, and you called it the 540 line, and by gosh, that's where the rain-snow line was going to be. Well, this equated, as I just said, to a thickness of 5,400 meters, but that layer is over 3.5 miles thick, and there's an awful lot of detail within that 3.5 mile layer that has to be accounted for, and this averaging out over that big of a distance can definitely cause problems. So alas, yours truly had a revelation on January 19th and 20th in 1978. I was in my junior year at Penn State, and I was forecasting for a radio station in Baltimore, Maryland, and those of you that may have lived in that area at some time may recognize these call letters. It was WCAO, and they hired me as a college student. They knew they were accepting a huge risk, and they paid me $50 a month, which I thought was pretty good money back then. And it was great experience, just phenomenal experience. So the 1,500 millibar thickness around Baltimore and Washington was forecast to be 546, which is way above 540. So it was an easy forecast, right? I just called for all rain, went back to my apartment. I think I had a test the next day, so I was studying for that. And then somebody called me from the weather tower, the weather observatory, and said, I just thought you'd like to know, Greg, that at Wallops Island, Virginia, the visibility is a 1/16 of a mile in heavy snow. And we kid around a lot, and I said, look, I'm studying for a test. Please, not now. I'm not in the mood. And he said, Greg, I'm not kidding. And so I ran into the weather station and found out it was snowing like a bandit in Baltimore. It did eventually rain, but it was all freezing rain and sleet, and only after half a foot of snow had fallen on top of them. Okay, so what the heck happened? Well, the 1,500 millibar thickness actually verified at 546. So that wasn't the problem. It wasn't a bad model forecast, but the devil was in the details. There were unusually warm temperatures way up in that layer that distorted the overall thickness value to higher than you would think it would be for a snow situation. But way up there, it's almost always cold enough to snow anyways. So it doesn't really matter if it's unusually warm. If it's below freezing, then you're still going to get snow. And so that was the one thing I had never seen before. And so this is the actual data from Washington Dulles Airport at 7 p.m. on January 19th. This, I believe, was a Thursday night. And the height in meters is along the y-axis over here. The temperature in degrees Celsius is down here. So remember, the freezing temperature would be 0. And I've outlined that freezing level here in a red line. So you can see the entire sounding is below freezing at 7 o'clock when the precipitation was just about starting. And so obviously you would go for snow in a situation like this, even though the 1,500 millibar thickness was over 540 already at this time, but the temperature at 500 millibars was about minus 15, and that's really warm for the wintertime. I mean, that would be a temperature you'd expect to see in the mid to late spring, okay? So again, those warm temperatures up here distorted the thickness value upward, but it didn't matter because it was still minus 15 C or about 5 degrees Fahrenheit, so still plenty cold enough to snow. Then the next morning, look at this. When it finally did change over to freezing rain and sleet, it wasn't because of any warm air in the lowest 5,000 feet of the upper atmosphere. It was up here between 5 and 10,000 feet, and the temperature got almost up to 40 degrees about 6,000 feet above the ground, okay? So again, when you average out something over a huge layer or huge distance, there can be all sorts of ways that the details can add up to that average. But the details are what determine what type of precipitation you get, and that's simply just too big of a layer to deal with. So what we started doing was using things like the 1,850 millibar thickness, which is like the lowest 5,000 feet, and then 850 to 700, which is like 5 to 10,000 feet, and that would have easily picked up on this warm nose here. So I promised earlier I'd tell you about how the National Weather Service contributed to this precipitation-type forecasting effort. There were actually a couple of people involved, and I know Kermit Keeter was involved, and I think Rod Gonski was working with him on this. And if I left somebody out, I apologize. But they went back and took a look at virtually every winter storm in North Carolina for heck knows how many years, and looked at the thickness values and came up with this matrix here, where here's the 850, 700 thickness along the bottom, 1,850 thickness up here, and here are the different zones. This is all snow, this is snow and sleet and freezing rain and rain, wintry mix, all rain, and so forth. Now, based on the American model this morning, we are in the ZRIP category, but it doesn't matter because it's dry, okay? Now, one of the nice things about this program, and this program again is called BUFKIT, you can trace the precipitation type and the thickness trends over 48 hours. So this is what it looks like 48 hours from now, and you can see that line steadily moves from the freezing rain and the sleet to freezing rain and rain to all rain by the time we get to Thursday, and that is the next day that we're forecasting precipitation. So just by looking at that, you know, it just confirms the idea that it's going to be rain and nothing else for us on Thursday. But the work that they put in to come up with this chart was so valuable that the person that wrote the BUFKIT program decided to make it a piece of the software. And so it's now not just used locally, but used all over the country. Now, it doesn't work real well in the mountains, okay? But if you're anything close to sea level, then it gives you a really good first guess as to how things are likely to transpire. All right, that is it for today. Bonus weather video number 1 for the week. Now, I'm going to be traveling to New York City on Thursday, Friday, and Saturday. This is my Christmas present to myself. I'm going to see a couple of concerts at Lincoln Center, where I've never been there before, and a couple of other cool things. So again, my ability to go into a lot of detail like this is going to be very, very limited, but I'll do something so that we can keep in touch. And then next week we should be back to normal. Hard to believe that Christmas is a week from Sunday, huh? Man, time flies when you're getting old. All right, that's it for now. You all have a wonderful rest of your Tuesday, and we'll talk to you soon.